Converting strings to datetime and extracting components in Pandas. In this lesson, we will learn how to work with dates and times in Pandas. You will see how to convert string columns to real datetime types. We will also learn how to extract useful parts, like the year, month, or weekday, for analysis. Handling dates is an essential skill in data analysis, finance, and much more. Running the cell now. We want to turn off any annoying warning messages. This helps us focus on learning instead of warnings. Now, let us get the sample flights dataset from Seaborn. It has columns for year, month, and number of airline passengers. We load Seaborn to access the dataset. Import NumPy as NP. Import Panda as PD. We set the random seed to 42 for reproducibility. We load the flights dataset into Pandas as a data frame we call df. Let us check how many rows and columns we have. Here is a sneak peek at the first 3 rows, so we know what data we are working with. Running the cell now. This dataset contains 144 rows and 3 columns showing monthly flight passenger counts from 1949 onwards. Notice the year and a month to columns are strings, key to understanding why we need to convert them to datetime for time series analysis. This setup prepares us to practice converting and extracting date components effectively. Why are datetime types useful? Most real datasets have dates as strings. Dates as true Pandas datetime types let you sort, filter, plot, and extract features easily. Let us look at the columns of our dataset. Running the cell now. We see our column names, year, month, and passengers. Now we print the data types for every column. Notice that year is int, month is object, and passengers is int. Running the cell now. Here, we see the column names and their data types, revealing that year and passengers are integers whilst month is a categorical type. Notice there is no datetime type yet, which means dates are not fully prepared for time-based operations. Converting these columns to a proper datetime type will enable easier sorting, filtering, and analysis in upcoming steps. We combine the year and month columns into one text column. First, we change the year to string, join with a dash, and add the month. Let us see what our new column looks like. Running the cell now. Here, we see how year and month columns are combined into a single string representing a date, which is a common first step in date processing. Notice the consistent year-month format in the new date_str column, which sets us up for converting these strings into Pandas datetime objects. This conversion is crucial to leverage powerful datetime functions for sorting, filtering, and analysis later in the lesson. We attempt to sort the data frame by the date_str column. This prints the first 3 rows after sorting, showing the order by the date_str text. Running the cell now. Here, sorting by the string-based date_str column does not order the months chronologically but alphabetically, which can lead to misleading results. Notice that April appears before August and December, but months like January or July might be out of logical sequence. This highlights the limitation of string dates and motivates converting them to true datetime types for proper sorting and analysis. Converting date strings to real datetime. Pandas can turn many kinds of date strings into datetime type with the to_datetime function. This will allow powerful date operations. Running the cell now. We use Pandas to_datetime function to change our text column into a datetime column. Here you see both the old string and the new date values. Running the cell now. Here, we see the original to date_str column of year-month string successfully converted into full datetime objects in the date column. Notice how Pandas automatically fills in the missing day as the first of each month, enabling precise date operations later. This confirms that to_datetime correctly interprets the format and transforms strings into usable datetime types. Let us check if the column is actually a datetime object. It should say Pandas timestamp, which is how Pandas represents real dates. Running the cell now. The output shows that the date column value at index 0 is now a Pandas timestamp object, confirming the successful conversion from a string to a datetime type. This is key because it enables powerful date operations, like filtering or extracting parts of a date, which weren't possible with plain strings. Date features, extracting year, month, and more. Once you have date times, you can easily get features like year, month, quarter, weekday, day, and more. These are just attributes of the Pandas datetime column. Running the cell now. We create a new column for year, extracted from the real date. We also create a column for the numeric month. Let us get the weekday as a number. Monday is 0, Sunday is 6. Let us look at the new columns we made, side by side with the date. Running the cell now. This output shows how the original the date column is transformed into separate features, the year, month number, and weekday as numerical values. Notice that the year stays consistent at 1949, while the month increases from 1 to 5, and the weekday varies, with 0 representing Monday and 6 Sunday. This illustrates how Pandas datetime attributes let you easily extract meaningful time components for further analysis. Sometimes you want to have the actual day of the week name, like Monday or Tuesday. Pandas makes this easy with the day_name method. Let us print a sample to see the weekday names. Running the cell now. This output shows how the code extracts the weekday name from the datetime column, adding it as a new weekday_name column. Notice how each date now has the corresponding day of the week spelled out, which helps in understanding temporal patterns or grouping data by weekdays. This demonstrates the ease of accessing date components with Pandas datetime attributes for more insightful analysis. Let us try to find which date in the dataset had the most passengers. We first get the row with the highest passenger count. Now let us print the date and the number of passengers for that row. Running the cell now. Here we used the IDSmax method to find the index of the row with the highest passenger count, then accessed the corresponding date and passenger values. Notice how the output shows July 1st, 1960, had the most passengers, with 622. This illustrates how we can pinpoint specific dates of interest by combining datetime indexing with data aggregation. Your turn. What weekday was the best for airline travel in this dataset? Pause and try extracting this on your own. Now, let us see which day of the week had the most total passengers. We group the data by weekday name, sum up the passengers, and sort from highest to lowest. This shows us which day was busiest across all years. Running the cell now. This output shows the total number of passengers summed for each weekday, ordered from highest to lowest. Notice Friday and Tuesday have the largest passenger counts, highlighting how grouping by the extracted weekday_name lets you identify trends and patterns in the data by day of the week. This demonstrates how datetime attributes enable straightforward aggregation to gain insights from time-based features. We can filter the dataset to just see the weekends. We use the ISIN function to pick rows where the weekday is Saturday or Sunday. Here are the first few rows of data for weekend flights. Running the cell now. Here, the output shows only the rows where the flight dates fall on weekends, as filtered by checking if's weekday_name is Saturday or Sunday. Notice the columns year_extracted and month_number confirm the correct extraction of year and month numbers, and that the weekday_name column properly identifies weekend days. This demonstrates how you can use date attributes to segment and analyze data based on specific time-related criteria. With real dates, we can make a nice line plot showing airline traffic over time. We import matplotlib for plotting. Let us make the figure a bit wide, so it is easier to read. We plot date on the x-axis and passengers on the y-axis, and add markers to each point. Give the plot a title to describe what it shows. Add a label to the x-axis for clarity. Add a label to the y-axis too. Turning on grid lines helps make the values easier to follow visually. Tight layout prevents text from overlapping. And finally, we display the chart. Running the cell now. This plot shows how the number of airline passengers changes month by month over the entire time period, using the datetime values from the date column as the x-axis. Notice the clear upward trend and the seasonal peaks occurring roughly every year, which highlights why extracting date features like year and month is useful for analyzing patterns and trends in time series data. Real-world tip. Always convert date columns to Pandas datetime as soon as you load new data. That way, you avoid sorting bugs and can easily use date filtering or extraction features. Running the cell now. Let us practice by picking all the rows where the flight happened in the year 1952. The DT accessor makes filtering by year quick and readable. Here are the first few rows for 1952. Running the cell now. This output shows the first few rows of data from the year 1952, filtered using the .dt year attribute on the datetime converted a date column. Notice how the dates are now properly recognized as timestamps, allowing us to easily select all rows from 1952 without sorting issues, demonstrating why converting date columns to Pandas datetime is essential for accurate filtering and analysis. Let us answer another question: how many passengers did July flights have on average? We filter for rows where the month is July and then calculate the average of the passengers column. We print the result with 2 decimal places. Running the cell now. The output shows VNAN because this month the column likely isn't recognized as a proper datetime or categorical type, causing the filter df month equals Julys to fail. This highlights the lesson's point: converting date columns to Pandas datetime is crucial for accurate filtering and calculations based on dates. Without this conversion, operations like extracting or comparing months won't work as intended. Practice: try finding the best and worst months by average passengers. If you are getting value, remember to subscribe for more lessons on Pandas. It is common for real data to use many different date formats, and sometimes values are missing. Here we make a Pandas series with 3 example dates in different formats. We use _datetime again, letting Pandas auto-detect the format, and coerce errors to NAT if parsing fails. Let us see how Pandas matches or fails to parse each original string. Running the cell now. This output shows how PD_datetime attempts to parse different date formats, but fails on the second and third rows, resulting in NAT, not a time. Notice that only the first format, the 1st of March, 2022, converts correctly because day first equals false doesn't match the others' formats. This highlights the importance of consistent date formats or specifying parsing options to avoid missing values when cleaning real-world data. Let us find the total number of passengers in the year 1950 as a sum. We filter our data frame to the year 1950 and sum the passengers column. Then we print the result. Running the cell now. Here, the code filters the data to include only rows from the year 1950 by using the datetime conversion, then sums that passengers column to find the total for that year. Notice how converting a date to datetime allows easy extraction of the year for filtering. This demonstrates the real-world tip: datetime conversion simplifies date-based operations like resampling or slicing, preventing sorting errors and enabling precise analysis. Now let us practice. Type a date as a string in year-month-day format, like 2024-05-15. We use input to read the string from you. We convert your input to a real datetime using Pandas. Let us show you the date as Pandas understands it. You also get to see the year, month, and day as separate numbers. Running the cell now. This output shows how a user-entered date string is converted to a Pandas datetime object, with the time defaulting to midnight. Notice the key benefit: you can easily extract the year, month, and day as separate integer values for further analysis or filtering. This reinforces the lesson tip to convert date columns early to unlock powerful Pandas datetime features. Review and next steps. Today you learned how to convert strings to datetime and extract date features in Pandas. You practiced with the flights dataset and saw common real-world tasks for dates. Next, try using these skills with a new dataset, perhaps Titanic or your own CSV with a date column. Remember, always check your date columns and convert them early. Running the cell now. If you like this lesson, like and subscribe to our channel for more tutorials, tips, and projects. Let us know how you use Pandas dates in the comments below. Happy coding! Running the cell now.